Okay, it is running. And hi and welcome to our first live stream in English. And today, let me close this door. Okay, our first live stream going to be a local binary pattern. And local binary pattern is a method based on textures, and it is used for facial expression recognition and facial recognition. Okay. Come here. It's my cat. She want to stay in the live stream. Okay, in the next weeks I'm going to make these live streams in both in English and in Spanish, and now I'm going to speak in Spanish just a little, and then I continue the tutorial in English. Muy bien, a partir de esta semana he decidido empezar a hacer este tipo de live streams en los que primero lo voy a dar en inglés y después lo voy a hacer en español. Así es que si este video ya está arriba y quieres verlo en español, te voy a dejar por acá una tarjeta. Si no, si estás viendo en vivo, bueno, pues puedes cerrarlo y en unas horas podrás verlo ya en español y completamente en vivo, claro. Bueno, entonces vamos a cerrar esto para que podamos ver bien el código y let's start. I mentioned that a local binary pattern is a method based on texture for image, and is used for facial expression recognition and facial recognition. It could be used for reduce the number of features in classification process. An example is when we use a convolutional neural network, we give to the neural network the full image to the classifier. Okay, with local binary patterns, we decrease the number of features because we only extract a histogram of all the image, and this going to be our features of our system. Okay, I'm going to check this. Okay, this is a okay, this is the image. Here is the how the method consists of, how consists the method. Sorry, I have bad English, sorry for that. Here's the function, or here is the process of the method. Okay, we have an image that is a set of pixels. Then for each pixel we have a central pixel of a region in the image. Okay, here in this region is a region of 3 by 3. In this region we will apply this method. The central pixel will be our first value. This is here the value of pixel, and then we're going to find a binary number, like here. I don't know if the cursor, yeah. Okay, this is not here. Okay, let's continue. Okay, here we have a binary number that we're going to find, and here's our central pixel, and we will compare to the other pixels, the neighbor pixels. First, we going to start with the 18 in the left upper corner, and then we're going to continue with the 8, the 14, the 40, the 15, the 50, 10, 7, and 20 value. We will use this function. We have a value. The value of the pixel will be 0 if the pixel is lower than our central pixel, and 1 if our pixel is upper or pardon, major or equal to our central pixel. Okay, here's an example of this region. For 18 is major than 15, so we will get a 1. 8 is lower than is minor than 15, so we get here a 0. Then 15 is 14. 40 is major than 15, so here we got get 1. 15 is equal to 15, so we will get a 1, and we will continue with the other pixels. So finally we get here a binary number, and we will to make a conversion to decimal pixel. So here we have the sum of all the pixels, and we get in decimal number 185. So we will make this with all the pixels that we can do, because we can do for corner pixels or border of the image pixels, because we don't have the 8 neighbor pixels. Okay, and so we need only to apply to the pixel that we can do it. So here we have an image. Here's my cat, and we're going to apply a local binary pattern, and we will get a local binary pattern histogram. Okay, here's the code. We're going to import a matplotlib library and the pyplot method we have here. We will use an auxiliary list. This auxiliary list is for get the histogram of the local binary pattern, and this for loop is for initialize our histogram. Then we will use u equals 1. Here we use it as the delimiter of our image. So because we can apply this method to the border pixel. So here we use it for delimiter our region of apply this method. Then here is the LVP method. So here we in this line we get the neighbor pixels of our central pixel, and we have here a int number for sum all the results. Then here we will make a for loop in all the of my pixels, of my neighbor pixels. So we will make a comparison to our central pixel, that is a image dot item in the position I, j. Okay, here we have our image. So we will use OpenCV library, and we open our image. This is some image in JPG format here. Okay, so we make a zoom with our pose, and we will get this number. We don't make a conversion to binary number. We get directly the number. So if it is here the comparison, if it's lower, we will get 1, and we will zoom to the variable of summa in this case. If not, we only we make nothing. No, we will not count to the sum. Okay, so when we get this number, this number in this case, when we get this number, we sum 1 to that position. So if we have this example, I will have an array of 256 positions. So in the position 158, we will we will sum 1 to the number of pixels in that position. Finally, we get the histogram, and we will plot like this. And this kind of histogram can be applied to any classifier, supervised classifier, or not supervised classifier, or unsupervised classifier. Sorry. Okay, I finished the explanation. If you have any question, you can ask me in the chat box. Here's my cat. So go out, baby. Ok, si llegaste tarde, bueno, después de este live stream de patrones locales binarios en inglés, voy a hacer uno nuevo, pero lo voy a hacer en español. Bueno, como no hay preguntas, voy a continuar. Okay, so here you have in our description, let me see. You have in our description a video where a local binary pattern is explained in English. If you want to know more about a local binary pattern, you have this video. Is video 1 will be explained in the description of the video. Then you have a paper where a methodology for facial expression recognition is explained. So you can go to the paper and you will get I don't know, in your school, in the any page in internet you can get. And finally you have a data set that is half a data set of Japanese facial expression. I don't know the number of the data set, but you have there the data set. So we will make something like that is mentioned in paper 1. I don't know where I put the paper. I don't know. I don't find it. So we can go here. No, I don't want. I don't have it. I'm missing it. So in this paper so here we can get the paper. explain something. Okay, I find it. Okay, here's the paper, and is a method based in PCA, in principal component analysis, and in local binary pattern. Then he used super vector machines for classification stage. So they here combine two methods. Okay, I will show it in. Okay, here is our paper. Here's our paper. So here's the processing that they follow. First, they have here is the authors. Chongqing in China, sorry, China. So here's the methodology that they follow. So I'm going to put it here, and they have a data set. We have a free data set in the data set. Then they apply image preprocessing. I can see here. I don't know. I don't read the full paper, but I think that they use uh, a Violin Jones algorithm. So I don't know. I think that they normalize their pixels, and uh, then they use it for feature extraction stage. So they apply an image preprocessing stage, then they find the head position in the image, and they find the mouth region too. So they use both face image and mouth image. Then they applied a local binary pattern and used PCA to get the final features that they will use for speech recognition in super vector machines supervised learner. So we will make something like this. We have the face image collection. We will only find the head position, the face position. Sorry, the face position with the Violin-Jones algorithm, and finally we use this. Sorry. Then we will apply the local binary pattern algorithm to get the histogram of features, and finally we will use Weka to apply supervised learners. So here is the first part of the code. Mm, Sublime text. Okay, here we have a sublime text. Okay. We have here the sublime text. So first we can see that here have our folder of the dataset. In this in the directory is the folder that you where you have your dataset. the dataset is for free, and you can get in the description of this video. You can get the link to the dataset. Then we open a text file to write the features of our of dataset. So here we first we use this variable. Okay, we use this string to save the headers of our CSV file. Then we only use we get we put an h, then a number and a comma for in order to separate the headers of our file. Finally, we add the name of class and we print in the file. Okay, so we will use the files that have a TIFF extension, a TIFF format, and we will split here. We will split into the three channels of RGB color module. So we can this dataset of half a dataset have only is a grayscale dataset, so we can get any of the channels in RGB channel. But if you want to use a grayscale conversion of RGB, you can get you can make a grayscale image with that conversion, or you can split the image in any of the channels that you want to use. Then we have here other file. This is a Viola-Jones algorithm. Viola-Jones algorithm, and we will use this method that is Viola and Jones. We need to send the name of the image and then another image to extract those region of interest. So we can we return the left eye, the right eye, the mouth, the left eyebrow, the right eyebrow, and finally the face position, the face. Here we get that list of region of interest, but we will use only here. We will use only the face, and we extract the local binary pattern histogram of the face. We will get in a string the histogram, and finally we will write into into the file, the CSV file. Okay, then if you apply this algorithm, you will get something like this. Okay, I will show it in Excel. I can show it in Excel. Okay, I have a problem with CSV, so no. No, I can show it. I will open in Sublime Text another time in Sublime Text, so you can get something, a file like this. In the first line you will have the headers and class, and then you have the features, and in the last row you have the class of that line vector. So finally I want to show you the Weka classification. So I will eliminate that, and I want to capture my screen. Okay. Okay, I will capture my screen. Yes, here's my cat. Once time. So you can go. Vaya para allá afuera. Okay. So I will open. Minimize that. I will open my CSV file. You can open here. Go to open file and put CSV files. I have it in data, local binary patterns, data tree. First, I will apply a filter of normalization, and it is here in filters, unsupervised attribute, and normalize, and here will be applied. Then I will go to classify. I will choose and I will make 3 tests, 2 with support vector machines. Function is SMO, and I have a polynomial kernel. I will use a 10K for cross validation and make start. So we get 29% of correct classified instance, 63 correctly classified instance, and incorrectly classified instance 150. So we have a bad result of with super vector machines. So we can get a higher accuracy. Then I apply RBF kernel and start. Here we have a worse classification. We have a 15% of correct classification, 32 and 181. So finally I will show that we will choose the KNN pixel kind network pixels. We get here LACID and IBK classifier. We will use our K in equals 1. So we will apply this classification, and Surprisingly, I get a better classification than 32% of correct classification 17 and incorrect classification 153 instance. Okay, so this is the final part of my first live stream. I will have here. I have we obtain a path classification. The code we will we will in my GitHub, and I will put in the description later. So we have here bad classification. We don't have a 15% classification or over to 14 percent classification correctly instance. So in the next video I will explain other method of selection of instances that it is used. So in the next tutorial I will explain genetic algorithms for so I will divide it in three sessions. I will put my camera. I will divide it in three sessions. In the first session I will explain the genetic algorithms. Then in the second I will use genetic algorithms for knapsack problem, that is an NP problem with exponential time. And in the third session I will apply a genetic algorithms for easy instance selection or attribute selection. We can get a lower attributes and in order to have a higher classification. But it will be explained in the next video. So that's the final of my first live stream. I hope that you enjoyed this video, that you will can use in your classes or in your projects. Sorry for my bad English, but I don't English speaker. And thank you if you see the full video. Bye, and we will see you soon in the next live stream. Yes, I see you. This is my cat. And I will be talking in Spanish. Bueno, como ya les mencioné, pues estoy haciendo los live streams ahora en inglés y en español. Así es que, sorry, I will, así es que, perdón. Así que dentro de un rato voy a hacer este mismo live stream, pero lo voy a hacer en español para que no te lo pierdas y pueda haber una mejor explicación del método de patrones locales binarios y una aplicación que es el reconocimiento de expresiones faciales. So if you like this video, you can subscribe to my channel for the next session. So see you soon.